Welcome back to part 6 on composition of functions. This section really does take a while. We're going to look at the composition of f with g of 6 and also the composition of g with f of 6. And then let's see if they match. We also are going to look at the domains of functions, and so before we even start working on calculating these compositions, let's just figure out what the domain of f is. The domain of f of x is all real numbers, so negative infinity to infinity. And the domain for g of x is any interval that will make the square root of x minus 6 positive. So x minus 6 has to be greater than or equal to 0. That means that x must be greater than or equal to 6. So our domain for g of x has to be on the interval from 6 to infinity, including 6, and we don't include infinity, at least not in this class. So find the requested value. F composed with g of 6 can also be written f of g of 6. If we calculate g of 6, we get the square root of 6 minus 6, which gives us 0. That means that f of g of 6 can be rewritten as f of 0, and we know that if we're substituting 0 into the function f of x, we can rewrite this as 0 squared minus 7. If we simplify that, we know that f of g of 6 is equal to negative 7. Now let's do something similar with g of f of 6. F of 6 is equal to 6 squared minus 7. If I simplify that, I get 36 minus 7, which is equal to 29. Then, if I substitute that into g of x, I have g of f of 6 is equal to g of 29, and g of 29 is equal to the square root of 29 minus 6. If I simplify 29 minus 6, I get g of f of 6 is equal to the square root of 23. And we can see by inspection that f of g of 6 does not equal g of f of 6. So we can make an assumption from just this one example. The hypothesis might be that f of g of x does not necessarily equal g of f of x. And if that is something you are thinking right now, that's a good thing to be thinking, because that's actually quite true. Let's find the requested functions and their domains. If we look at f of g of x, we will see that we can substitute the square root of x minus 6 into the f function. This simplifies to x minus 6 minus 7, or simply f of g of x is equal to x minus 13. Since there were no restrictions on f of x, but there were restrictions on g of x, we know that the domain of the composition will be the smallest intersection or overlap between the domains, which is from 6 to infinity. For g of f of x, we have the outside function, which is g of x, and we have a substitution for the variable minus 6, into which we substitute f of x, and we know f of x is x squared minus 7. From here we can simplify this further. We can write this as the square root of x squared minus 7 minus 6. Well, if we rewrite that, we can say that g of f of x is equal to the square root of x squared minus 13. For our domain, identify what restrictions are on the outside function so that when we put x squared minus 7, which doesn't have any restrictions on the domain, into g of x, we are calculating values that will not cause problems. So if I look at x squared minus 13, the domain will be negative infinity to the negative square root of 13. We can include the endpoint union positive square root 13 to infinity. It might also be helpful to look at the graph of this function. You can see that the function x squared minus 13 is negative between negative root 13 and positive root 13. So we throw out the domain values where there is no intersection between negative infinity and positive infinity and the domain of g of f of x.